In this tutorial, we will show you how to create a powerful NFT smart contract written in Solidity. We'll break down a contract that contains essential features like minting, burning, and transferring NFTs. We'll explore how it leverages the OpenZeppelin ERC-721 standard for secure token management. We'll also review how to integrate custom functionalities like setting a mint price, withdrawing funds, and emitting custom events. Finally, we will deploy and verify our contract on the Sefolia test network. By the end of this tutorial, you'll understand how this contract can be the backbone of your next NFT project. Let's get it started. Okay, let's create our NFT smart contract. We have several options. We can start from scratch or use some templates. For instance, here in Remix, we can create a new default workspace and use a template. We just need to come to this section, default workspace, and select the option create a new workspace. Now you'll see that you have several templates, Solidity-based templates, zero knowledge proofs templates, etc. And also you want to create your ERC20 token, you can do it as well. If you filter this list by just checking ERC-721, you'll have some generic options. For instance, you can create a simple ERC-721 project or a more complex project that will allow you to mint and burn tokens. Let's select this second option. Let's create a new workspace based on this template. Let's leave the name ERC-721 NFT. Select OK. And now we have created our project here in Remix to use the template ERC-721. Let's close these folders, script test. In this folder contracts, you'll have the file mytoken.sol. Here, you have a very simple smart contract that is calling or importing these libraries, the basic standard ERC-721, the burnable library, and also the library ownable. And this is implemented because we also want to implement some access control features. Let's move on and see what we have here. Using these libraries, we'll have the option of creating, minting, and also burning some tokens. This is a very useful approach if you want to create a very simple NFT. However, the problem starts when you want to modify this smart contract. Okay, so if you want to add a new library or a new feature, you'll see that you'll get into some troubles. Okay, so the second option is to use the OpenZeppelin's wizard. Let's go to the website openzeppelin.com, and you can come here to the section Contracts Library. Here, just select the option Contract Wizard, and you'll see that you have several options to create some smart contracts. For instance, select the option ERC-721, and you can also create a new smart contract by adding this feature, mintable, burnable, but also let's see that we want to improve the way we implement the URI storage for linking our tokens to an image or a video or some other kind of file, like a document, etc. So you can notice here that this smart contract is exactly the same or very similar to the smart contract that we just create here. We are importing ERC-721 library, burnable, and in this case, we are importing the same options. But what if we want to import something else? As you can see here, the wizard starts creating new functions that are mandatory for otherwise this is not going to be executed. For instance, let's just copy this ERC-721 URI storage here, and you'll see that this project is not going to be compiling anymore. Let's now inherit this library here. I'm going to put it in this section, and you'll see now that I'm not compiling this. Also, very important, remember that we need to specify the Solidity compiler. Here, we are using or allowing the compiler to compile this contract by using any compiler that is greater than the version 0.8.20. In production, you should specify the compiler that you use to make sure that you're introducing new bugs by allowing the Solidity compiler to compile your contract using a more advanced compiler. So in production, specify your Solidity compiler. Okay, now let's go back to our contract. We are now importing and inheriting the library ERC721 URI storage. So what's happening if we want to inherit this library? We have an error because now we have a problem. There are two libraries that are using the same functionality. The ERC721 standard is also using a function that is going to be used here in this new library. So we need to specify which one we are going to use. Let's go back to our code. Here, this is the function that we need to specify. I'm going to copy it here. And now we have a different error because now we are specifying which one do we want. But the compiler is also asking us to override the function supports interface. Let's go to the wizard. As you can see here, the wizard is creating a new function that implements and overrides the function supports interface in both smart contracts, ERC721 and ERC721 URI storage. So let's add this new function here. So let's review what we have so far. We are importing 4 libraries here. We're importing the ERC721.sol file that is taken from the OpenZeppelin contracts library. We're also importing the burnable library that will allow us to burn the tokens, the library URI storage that will enhance the way we link our files to this smart contract. And also, we are adding some access control to our contract. In this section, let's verify the compiler. We are using the version 8.20 to compile this smart contract. We can increase the version here to 24, and Remix will update the compiler in this section. The compiler will be the same as the one we are specifying here. So remember this because it's very important. Let's go back to our contract. So here we are going to inherit these libraries, and in the constructor we have the owner of this smart contract, or we are specifying the owner of this smart contract. We can receive an address, or also we can specify that this will be the message sender. This will be the address that is deploying this smart contract in the blockchain. So let's say that at this moment we are going to use the initial owner. When we create our NFT smart contract, we specify the name of the token and also the symbol of my NFTs. At this moment we have the constructor, and also we have another function that is called SafeMint that will allow us to create a new smart contract, and it will verify 2 things: that the receiver is not a smart contract, and also that if this function fails by any reason, this is going to revert. So it is very important to use the SafeMint option. Now we have override these functions, token URI and supports interface. This function is marked as virtual in the libraries, and here you are overriding in both contracts, ERC721 and ERC721 URI storage. The same happens here. The supports interface ensures compatibility with different interfaces and confirms that the contract supports the ERC721 standard and other interfaces. Okay, so we need to override these 2 functions. And now let's check what do we have here in this smart contract. Let's go to the section and let's deploy our smart contracts. Let's go to this section here and let's deploy the contract to the test network. Here you have the environment Remix Virtual Machine Cancun, so this will be fine. You have several accounts with some Ether, and also, well, you can estimate or define the gas limit. Don't do it now. We are fine with this amount. You can send some Ether if the constructor is payable. That means that the constructor will be allowed to receive Ether. And let's deploy the tokens. Okay, so now if we want to deploy our smart contract, we need to specify the initial owner. Let's copy here my account, and then let's deploy the contract. There you go. So voila, now we have a lot of options. What does this mean? These functions are the functions that are being inherited from the library. So that's why we have a lot of features and options here. After we deploy the smart contract, we also got some information. This is the transaction hash. Also, this is the hash of the block where this transaction was mined or validated. This is the contract address, and this is the sender or deployer of this contract. Okay, this is the amount of gas that we invest here and the execution cost. This is the bytecode of this smart contract, and also some logs that we obtain here after we deploy the smart contract. Let's pay some attention here. The previous owner of this smart contract is the address 0, but the new owner will be the initial owner argument that we send when we deploy the contract. Okay, in this case, this is my address. Okay, let's continue and let's explore a bit more about this smart contract. So we want to check the name of the token. You just need to click here in the section in the function name. The owner will be this address, and the symbol will be MTK. Let's mint our first token. To mint our first token, we need to call the function SafeMint. To call this function, we need to send some parameters or some arguments. We need to send a value to the parameter 2. We also need to send the value of the token ID. And remember, only the owner of this function will be allowed to mint this token. This is a modifier. This modifier is part of the ownable library. So you don't have to implement your own access control feature or smart contract. You can just call the modifier only owner, and this will prevent that other account will mint a new token if this account is not the owner of the contract. Okay, so let's mint our first token. Let's go here and let's create our token. Let's specify the address of this new token. Let's select here the second account. I'm going to copy this account. I'm going to copy the account here, and in this case I can specify the token ID. The token ID will be 5. I'm going to send this transaction, and also I have some results here. Let's explore what do we get here. Again, we have the transaction hash. The block number in this case is 2 because Remix means a new block every time we send a new transaction. I am the account that sent the transaction, and here we have some logs. In this case, for these logs, this is the address that was the previous owner. This will be the new owner and the token ID. Now, how can we get some information about this new token that I just minted? What is the balance of this address, CB2? I'm going to call this function, and CB2 is the owner of the first token. So in this function, I can get how many tokens this account has. It is, in this case, this address has 1 token. Let's check who is the owner of the token ID number 5. This function, owner of, will return the address that is the owner of this token ID. Of course, the token needs to be minted first. In the case of the token 0, if I select here, I'm going to get an error because this ERC721 token it does not exist. Okay, so now I can mint a new token, or I can transfer this token to another account. Let's see that now I want to transfer my token to the owner of the contract again. For instance, let's go to I'm going to copy this, and I'm going to transfer my token to a new account. Check this. I have two functions: save transfer from, and also save transfer from, but with an extra parameter. In this case, some data. Because I don't have that data here, I'm going to use the function save transfer from. So now I'm going to use this address. I'm going to copy this address here as the receiver of the token. I am the owner, so I'm going to select this account because I'm the owner. And now what I'm going to do, I'm going to send from my account to this new account this token with this ID. So let's clear here and let's send the transaction. And now if I ask who is the owner, I should get the new address. But let's check first what do we have here. In these logs, we have that this token was sent from this account to this new account, and this is the token ID. So who is the owner of the token ID number 5? So voila, this is the new owner. So as you can see here, I can mint tokens, I can transfer those tokens, and also I will be able to burn some tokens. I am the account C4, and then if I want to burn the token, I just need to specify the ID and select and send the transaction. And now you'll see that the logs were correctly, that the function was correctly executed. I got the logs. And now let's see how many tokens do I have here. CB2 has 0 tokens. My address C4 has also 0 tokens. Let's balance off. Let's copy the new account address. Let's call this. And also has 0 tokens. And the owner of 5 will be an error because this ERC721 token does not exist. We were missing something. When we created our token, we need to specify a URI. Actually, if we come here to the OpenZeppelin wizard, to mint a new token, we have an extra parameter, the URI. Let's copy this line here and let's set the URI of the token. So what does this mean? This means that when I create a new ERC721 token, I'm going to associate this token with an address. This address will be the URL to an image, an MP3 file, a PDF file, whatever you want. So here we only need to specify this parameter, which will be a string. Let's specify the name of the parameter URI. Let's redeploy our contract. Let's come to this section. Let's clear the instance of this smart contract. And then let's create a new token. To simplify this, I'm going to erase this initial owner address. And I'm going to specify that this message sender or the sender of or the account that deployed this contract will be the owner. So this will help us to simplify the code of this contract. Just a little bit. And there you go. Now we can deploy again our smart contract. Let's deploy it by sending a new transaction. If you check who is the owner of this contract, now I am the owner because I just use my account to send and deploy this contract. Now let's see how can we meet this smart contract. And the address, again, I need to specify who will be the receiver. It's gonna be my account. The token ID is gonna be 1, and also the URI will be a URL. You can specify anything you want here. Remember, if you want to specify or you want to store your files that were stored in some service like Piñata or NFT storage, you need to specify the URL here. This is the link. Voila. So this is just a link that this is a dummy link, of course, that we are going to use to specify the address where we can retrieve the smart contract. Remember that we cannot change this in the future. Once we associate this link to this token, we cannot change it. We can burn the token, but we cannot specify a new URI for this token. at least not in this contract. You can, of course, create new functionality or modify the core of this library, and you can do whatever you want. But for this standard, you cannot change the URI. So let's transact and create the new token. And for this token, now you associated the URI to the token ID number 1, and you can get the address where the image or the file was stored. So we have this smart contract, but it's not ready for production. For academic purposes, as a tutorial, is okay. You can deploy this smart contract and use it and test it and start learning, but this contract is far from being ready for production because you need to add more functionality. So please be cautious when you use a template or you use the wizard, because some people think that that will be enough and will probably skip hiring a smart contract developer because they think that this will allow them to create their NFTs. But this is not true. So what is the problem with this? What if we want to add new features or functionality? What happens if we want to mint a new token and charge for that token? How can we handle errors, or how can we add royalties distribution in our contract? Who is going to be able to mint this new token? Anyone, the new owner, etc. So there are a lot of things that you need to think about when you create a smart contract, especially if you're going to use this contract for creating a new collection that will be sell very or will create very expensive NFTs. So let's add some new functionality and you'll get my point. For instance, what happens if anyone is allowed to mint a new token, but they need to pay for that token? So the first functionality will be anyone can mint a new NFT, but they have to pay some Ether. So first we need a price, right? We need to declare a variable here that will be const uin 256 a constant variable that will be public and will be the price, let's say 1 GW. So now we have the price. Now we are saying here that anyone can mint a token. So you don't need to be the owner, because anyone that has the money can mint a token. The first thing that we need to do here is to verify if the sender of the transaction is paying enough money here. We need first to declare this function as payable, because we are going to get some Ether, and we need to verify that the global variable message value will be greater or equal than the price. If not, we are going to send an error. This is called a custom error. So here I'm going to create my error that will be not enough Ether, and I'm going to send the value here. The equivalent to this is to use a require statement. We can do it both. We can add a require here saying that the message value, this is gonna fail if this is less than the price. If this message value is less than the required price, this is going to be reverted. In this case, if the message value is less than the price, requires that this is going to be greater than the price, otherwise I will send an error message here. So these two ways are equivalent. Here I'm using a custom error, and here I'm using a require. What is the difference? The difference here is that using custom errors will be cheaper, but to be honest, I really like this notation. So this is in one single line. If you're reading this contract, will be easier to understand. You don't need probably to use 2 lines of code. This is up to you. Let's just comment this line of code and use the custom error. It's okay for now. So if you want to buy this new token, you need to pay for that token, and also you will be check if you're sending enough Ether. if you have noticed here, we don't have events. So let's create an event. New mint, new token mint. And the reason because we don't have events here is because when we use this function and we use this internal function save mint and set token URI, these new functions are triggering their events. So inside these functions, you have some events, the same here. So that's why we do not specify new events. But for the sake of this tutorial, let's create a new event. To print emit, let's create, what is the name? The name is new token minted. Okay, here will be, new token minted. Let's use the variable token ID here, and also the message sender. So this user is token ID message sender will be equal to uint256 token ID and address sender. Remember, the names in this event are for indexing purposes. Also, you can index, for instance, here you can use the word index to retrieve your events more faster. There you go. So now we are able to pay for a new token, and we will receive the Ether, but we are missing something. We need to check the balance of the contract because we don't know how much money do we have. So let's add this new functionality. Function get contract balance. This function will be public, and then will return uint256 value. And here I'm going to return the balance of this contract. Okay, we are missing something. This is probably returns, and also this is going to be a view function. There you go. We are also missing something else. If I am the owner of this contract, I need a way of retrieving the Ether that was sent to this smart contract. So I need to add a new function to withdraw the Ether. So this will be function with withdrawal. I don't need to specify the amount, but this will be an external function. This will be a payable function because we are going to need to send Ether to an account, and we'll return a uint256 value. Okay, now this function will return a uint256 value. Let's get the contract balance. I don't need to specify the amount. Let's just retrieve the entire amount in this contract. So let's declare a new balance here, a new variable here that will be balance equal to the contract balance. And now I need to send this value to the owner of this contract. So to do this, I just need to use a low-level call, which is the best way to do it. This low-level call will be done by saying message.sender.call, and also I'm going to specify the amount of tokens that I'm going to send from this smart contract to my account. So what are we doing here? Actually, I don't need to specify that this function will return a uint256 value. I can specify that it will return a Boolean value, just to specify that the transaction was correct. Here I will return status, and there you go. So what do we have here in this withdrawal function? This function is external, it's payable, and only the owner of this contract is able to call it. This function will return a Boolean value, just to specify that the withdrawal was successful. I'm going to get the balance of this contract, and I'm going to send it to this account. I can specify sometimes that this is the address. In this case, I don't need to do it. Actually, I can remove this parenthesis here. I think so. Let's just check. There you go. So this is a low-level call. In this case, I'm not calling a function, but I'm just sending this value, this Ether value, to this message sender account. And because the message sender can only be the owner, so it will receive this balance. Now let's deploy again our contract. Let's deploy it, and let's create, and let's mint a new token. To mint a new token, I need to specify the right amount of GW, and let's call the function SafeMint. Here, the address will be the address that ends with CB2. The token ID, I'm going to create the token number 10, and here let's add a dummy link, and let's send the transaction now. Now the owner of the token ID 10 is my account, or is this account. Let's verify how much Ether do we have in this contract. We have 1 GW. If I try to withdraw that amount, I'm gonna get an error message because I'm not the owner of this contract. So let's change my address, and let's call again the function withdrawal. If I check the balance of the contract, now the balance of the contract will be equal to 0. If I check the log, in this case, after the withdrawal, the function returned a true value. So everything was correct. Now let's deploy this contract to the Sefolia test network. Let's check the environment here. We need to change the environment to MetaMask. I have here my MetaMask account. I have selected the Sefolia test network here. I'm gonna enter my password, and let's check one of my accounts that have some Sefolia Ether. I'm gonna use this account because I have some test Ether, and I'm going to deploy this contract to Sefolia. I'm gonna use the injected provider MetaMask option here. Notice that now the Sefolia network is selected, and I'm going to use this account from the MetaMask wallet that has this amount of Ether. There you go. So I'm gonna deploy it to the network. I don't need to set any parameters here, so I just need to execute deploy. Now I have a transaction here that I need to confirm in my MetaMask wallet, and I'm deploying the smart contract. The transaction is pending. Let's wait for a few seconds, and there you go. Now here I have the transaction hash. In this case, it's a transaction hash, but in the Sefolia network. Let's check this transaction. This transaction was confirmed, and let's go to the block explorer. There you go. The Sefolia test network is still working on this transaction. We can wait for a few seconds here. There you go. Now this collection was created in the Sefolia test network. Notice here that I'm using this account, and I'm creating this contract in the Sefolia network. And if you want to retrieve this collection, this is the address of the contract. Let's move to the contract address, and this was the transaction. This is the transaction hash, the block number, the age of the transaction, and also the transaction, the type of the transaction. There was a contract creation. Now, if we want to review the contract code, you can see here that you are going to generate the bytecode, and this is the code that the EVM will understand. Okay, so these numbers here, see these hexadecimal numbers, were sent to the EVM, and this contains the functions and everything, the opcodes to execute your smart contract in the Ethereum test network. If we want to see our code, we need to verify this contract. So we have the option here, verify and publish. Well, we can do it also from Remix. If you go to the main window in Etherscan, you'll see that you have the option sign in, and you will be able to create your API key. Because I already have that key and I don't want to show my private information, I'm not going to do it here. Okay, but here in Remix, you need to add the plugin Etherscan. Here, this is the plugin for Etherscan, and you need to copy in this section. When you select this plugin, you'll see several options. This is the selected network. You need to select a contract here. In this case, my token. We need the contract address here. copy, paste, and then we need to specify the public key. Let's save this. Oh, okay, there you go. We have the Cepholiat network, we have the contract name, the contract address, and we just need to verify it. Well, that was pretty fast. The verification request was submitted successfully. You need to wait for a few seconds. And if now we go back to the contract address here, you'll see here that now your contract has been successfully verified. Let's now go to the section contract, and now you are able to check the contract code. Remember that if you change something, this is not going to work. You have to verify a smart contract that is equal to the contract that you deploy to the main network or the Cepholia test network. And you'll see that now you have your code ready to be audited in the testnet Cepholia. Okay, so this is the end of this tutorial. I hope you learned something. Please remember to visit my website courses.dappdojo.com in case you want to keep learning and well, improve your skills developing smart contracts with Solidity. Thank you very much.